In this video, we're going to take a look at some triangle theorems. So our first theorem is the sum of the angles in a triangle theorem, or SATT for short. So the three angles on the inside or interior of a triangle always add up to 180 degrees. So we are going to take a look at an example. We've got a triangle with three angles. We've got x, 60 degrees, and 45 degrees. So I know that the three angles inside a triangle add to 180 degrees. So that means that x plus 60 plus 45, so those three angles together, are going to add up to a total of 180 degrees. From here, I can collect my like terms, so I can add the 60 and the 45 together. So 60 plus 45 is 105. So I have x plus 105 equals 180. And then from here, we are just going to solve our equation by taking that 105 to the other side and doing the opposite. So I'm going to get that x is 180, take away 105. So 180, take away 105 gives me 75 degrees. That means that x is 75 degrees. Okay, our second triangle theorem is the equilateral triangle theorem. So in our vocabulary, we said an equilateral triangle is a triangle that has three equal sides. You can spot that those sides are equal because they have the same number of tick marks on each side. And it also will have three equal angles. So I'm not going to write in that the rule here is that the angles are equal. I am going to write that underneath. And we're going to do a little bit of calculating before we figure out what to put in the blank, because I would like to figure out how much each of those angles actually equals. So I'm going to have to use a combination of our equilateral triangle theorem, otherwise known as ETT, and the one we just did, which was the sum of the angles in a triangle theorem. So looking at this triangle, I see that it has tick marks on all three sides, and it's the same. It's just one tick mark on each side, so those sides are all equal, which means that the angles in the corners are also all equal. So if this angle is x, this angle here will be x, and that angle there will also be x. Using our sum of the angles in a triangle theorem, or SATT, I know that the three angles in a triangle should add up to 80 degrees. So that means that x plus x plus x equals 180 degrees. I think I might have said 80 degrees a minute ago, but I did mean 180 degrees. All right, from here, I can collect my like terms. So I have x plus x plus x. Each one of those is secretly a 1x. So 1x plus 1x plus 1x will give me 3x, which equals 180 degrees. And then to solve for just x, we are going to try to cancel out or undo that multiply by 3 by dividing the other side by 3. 180 divided by 3, oops, I did 6, there we go, is 60 degrees. So x is 60 degrees. Now this isn't just for this specific triangle. Any equilateral triangle, every angle will always be 60 degrees. So the equilateral triangle theorem does say that these three angles are all equal. So x is equal to y, which is equal to z, but they all individually equal 60 degrees. So anytime you see an equilateral triangle, you can just say that angle in that corner is 60 degrees. Okay, up next we have the isosceles triangle theorem, otherwise known as ITT. So as we discussed on our vocabulary sheet, an isosceles triangle has two sides that are equal and one side that is different. It also means that it has two angles that are equal and one that is different. The two that are equal are always going to be where the two equal sides meet that not equal side. So in this particular triangle, the two angles that are going to be equal are these two here at the bottom, so X and Z. So in this particular triangle, X and Z are the same, Y is going to be different. So we're going to take a look at the example. So I have a triangle here. We have an angle of X and an angle of 70 degrees. I also notice that two of the sides have a tick mark on them, showing that those are the same length. So since these two sides are the same length, where those two sides meet that third side are also going to be the same size. So if this angle here is 70 degrees, this angle here is also 70 degrees because of the isosceles triangle theorem, or ITT. So ITT tells me these two angles are the same. Now, in order to find angle X, I actually need to combine this with our very first theorem, SATT, that says that if you add all the angles in a triangle together, it equals 180 degrees. So if I take X and I add 70 and then the other 70, I get 180 degrees. I would collect like terms to start. So 70 plus 70 is 140, and that still equals 180 degrees. And then in order to solve for X, I want to cancel out a plus 140 by doing the opposite on the other side and subtracting 140. And then 180, take away 140 is 40 degrees. So our X equals 40 degrees. Okay, we have one more rule, which is the sum of the exterior angles in a triangle theorem, otherwise known as SEAT. If I throw in the word triangle, it would actually be SEATT, but there is a reason why it doesn't have that extra T. We'll be talking about that probably in our lesson on quadrilaterals and polygons. But for now, this is SEAT, or the sum of the exterior angles theorem. So in our definitions, we said that exterior angles are the angles on the outside of a triangle. They're not just the reflex angles that go all the way around. They go between the end of the side and the extension of one of the sides. So there is something special about those angles on the outside, and that is that they add to 360 degrees. So if I add X plus Y plus Z, it equals 360 degrees. So we're going to take a look at an example. So I have a triangle, the sides have all been extended, and the angles on the outside are the ones that I've been given. So these are exterior angles. Now we know that exterior angles add to 360 degrees. So if I take X and I add 130 and then add 138, they should all together equal 360 degrees. We are going to collect our like terms by adding 130 and 138. That gives me 268. So x plus 268 equals 360. And then I will solve for x by subtracting 268 from the other side. So 360, take away 268, gives me 92 degrees. So angle X is 92 degrees. All right, I'll see you in the next video to take a look at how to use all four of these theorems when mixed together.